This video will cover Section 3 of Chapter 3 on designing studies. When we talk about the design of a study, we're talking about whether we're considering an experiment or an observational study. We'll talk about when we can establish causation, that is, a causal relationship between one variable and another. We'll talk about paired and two-sample designs and compare and contrast them. And we'll talk about the pitfalls of observational studies. First, let's review. Remember, there are 4 stages or processes of statistics. Data production, in which we obtain an unbiased sample. We talked about that in a previous video. Design a study that assesses sampled values of a single variable or a relationship between 2 variables, avoiding bias. Next, we have displaying and summarizing, probability, and statistical inference. In this lecture, we'll talk about designing studies. Let's look at a few definitions. An observational study is one in which researchers look at the values of variables as they happen naturally. For example, if researchers think that gender might affect height, this would be an observational study because they're looking at a person's gender and a person's height as they naturally occur. Observational studies can be retrospective, which means the researchers are looking at the values of variables as they have already happened, or they could be prospective, in which the researchers record what happens as it happens. A sample survey is an observational study in which researchers ask people to report values of their variables. One pitfall of these is that sometimes people report opinions or change the values of their variables based on what they think the researcher is looking for. An experiment is a study in which the researchers themselves select the values for the explanatory variable and observe what happens. Anecdotal evidence is personal accounts. These are, statistically speaking, unreliable, and we should avoid them when we can. Let's look at an example. In response to a newspaper report, a mother wrote to the editor, "I have a problem with a study that stated that breastfed babies are smarter than bottle-fed. My 10-month-old son has always been bottle-fed, and he is very smart. I have been told by his pediatrician that in some aspects he is ahead for his age. I feel that this study contains some inaccuracies. Obviously, the people who conducted this study have never met my son." What kind of evidence is this? This is a personal story, so it's anecdotal. Statistically speaking, this is unreliable. Now, consider these headlines. When your hair's a real mess, your self-esteem is much less. Dental x-rays might result in small babies. Family dinners benefit teens. Moderate walking helps the mind stay sharper. How convinced should we be that there is a causal relationship between these variables? Well, how convinced we are depends on the study design. Because different designs have different reliability levels, the first thing we need to do is identify what kind of design it is. Let's look at an example. Suppose researchers want to determine if TV makes people snack more. While study participants are waiting to be interviewed, half are assigned to a room with a TV on and snacks available, the other half to a room without a TV on and also have snacks available. The researchers then see if those in the room with the television consume more snacks. What type of study is this? Here, the explanatory variable is watching television. Since the researchers are assigning half to a room with a TV and half to a room without a TV, this is an experiment. Now let's look at the same situation, but this time I'll ask the class, how many of you tend to snack more than usual while watching television? What type of study design is this? Well, here the class is polled. So this is a sample survey. The values of the variable are chosen or reported by the subjects themselves. This time, let's say that our researchers give participants in the study a journal and ask them to record hour by hour what they do the following day, including watching television and eating food. Afterwards, the researchers will assess if people ate more while TV was being watched. What type of study design is this? Here, the researchers are not affecting the values of any variables, so this is an observational study. And they're looking at what is happening in the future. So this is a prospective observational study. Again, with the same question, but this time our data will be collected in this way. We'll ask participants to recall for each hour of the previous day whether they were watching TV and what food they consumed. What type of study design is this? Well, again, the researchers are not affecting the values of the explanatory variable, so this is an observational study. And the researchers are looking at what has already happened. That makes this a retrospective observational study. Let's look at an example of designing a study. Suppose we want to know if sugar makes children hyperactive. How can we test this? Using an observational study and using an experiment. The first thing to do would be to get our sample of children. Then we would want to measure how hyperactive those children are and look at how much sugar they take in. If this will be an observational study, we'll have someone, like maybe a parent, indicate how much sugar the children are consuming. If it's going to be an experiment, the researchers themselves must decide how much sugar each child can ingest. Observational studies have pitfalls. Again, let's suppose that we're looking at sugar intake and hyperactivity in children. And let's suppose that our study was an observational study. Our observational study showed that more children with high sugar intake were hyperactive. Can we conclude that sugar causes hyperactivity? The answer to this is no. Observational studies cannot be used to establish causation. The reason for this is that there might be a different difference between hyperactive children and non-hyperactive children that is somehow related to sugar intake. That brings us to the notion of a confounding variable. A confounding variable is a hidden variable that the researchers are not exploring, that is tied to the purported explanatory and response variables. Confounding variables are always a concern when we are running an observational study. So what do we do if we must always worry about confounding variables? Well, looking at our study relating sugar intake and hyperactivity, perhaps let's say that gender is confounded with sugar intake and activity. For example, maybe boys are more hyperactive and boys intake more sugar. Maybe the relationship between hyperactivity and sugar intake is not really a relationship at all. How can we take this into account? Well, the best way is to look at boys and girls separately. Look at boys with high and low sugar intake and their activity, and look at girls with high and low sugar intake and their activity. Gender is only one possibility, though. What other things could be considered as confounding variables in this situation? Well, there are lots of them. Age could be one. Maybe older kids intake more sugar than younger kids and are also more hyperactive. Maybe kids that take in a lot of sugar do so through sodas that contain caffeine, and it's actually the caffeine that's making the kids hyperactive. Maybe there are some artificial additives in the food or drink that contains the sugar that is making kids hyperactive. Perhaps the socioeconomic level of the families are a confounding variable. Perhaps the parenting style in use is confounding this relationship. There are countless others. One way to handle confounding variables is to control for them by looking at two different samples, one for each possible value of the explanatory variable. A two-sample design is a design in which we take samples from two independent groups and compare responses. If, for example, we think gender is a confounding variable, we can do a two-sample design with male and female groups. If we were doing a study of Wofford students, maybe we would do one sample of Greek students and one sample of non-Greek students. A paired design looks a lot like a two-sample design, but there is one difference. Here we're looking at a pair of response values for each unit. An example of this would be if we're worried about genetics and somehow is in some way confounding a situation. Maybe we take a pair of identical twins who presumably have the same genetic makeup, put them in two different groups, and look at what happens. Paired designs are also sometimes called matched pairs. Other examples besides twins are before and after studies, in which maybe you look at a patient's response to a drug and you measure their, let's say, their pulse before receiving the drug and then after. You also see siblings and married couples making up parts of a paired design. Let's look at another example. Researchers are again looking at the relationship between sugar intake and hyperactivity. A two-sample design would look at proportions of hyperactive children for two groups, one with low sugar intake, one with high sugar intake. How could we change this so that it's a paired design? One way would be to look at a pair of siblings or twins and see if the one that consumes more sugar is more hyperactive. Using siblings would allow us to control for parenting style, Considering twins would allow us to control for genetics. Either one of these designs could be an observational study or an experiment. Let's look at some other problems that we may run into with observational studies. Remember, there are two kinds of observational studies: retrospective, looking back in time, and prospective, looking forward in time. Let's start with prospective studies. Suppose that researchers are using a prospective study to determine if TV makes people snack more. So this is the situation we saw earlier, where participants are given journals and are asked to record in their journal when they're watching TV and when and how much they're eating. Can you think of a disadvantage to this? It could be that since people know that someone is going to be looking at the record of how much TV they watched and how much they ate, that might create a bit of a self-conscious feeling, and they might change the way they behave as a result. Or, since they are self-reporting, they may not be truthful about the results. Now let's say we do this as a retrospective study. Here, participants are asked to remember when they're watching TV and when and how much they ate. What's the disadvantage here? Well, again, people may not be remembering correctly, or if they do remember correctly, they may not tell the truth about it. Let's go back to the headlines we saw earlier. If we're trying to decide how reliable these claims are, remember that we want to know if this is an observational study or an experiment. If we're worried about confounding variables, that means we're worried that these are observational studies. If they're experiments, confounding is not a problem for us. So let's look at that first one. When your hair is a real mess, your self-esteem is much less. Is this an observational study? And if so, are there possible confounding variables? Or do you think this was an experiment? Without any more information, we can't say for sure, but this feels like something that would be done as an observational study. Assuming it's an observational study, what confounding variables might there be? This situation is actually one that we'll see in a homework exercise coming up in a couple of sections. Now let's look at this headline. Dental x-rays might result in small babies. Was this an observational study? And if so, what could be confounding? Even without knowing more, we can be almost positive that this was an observational study. Why? Well, if we suspect that X-rays actually do harm to babies, it would be unethical for the researchers to expose mothers to something they think might be harmful to their children. There aren't any immediately obvious confounding variables. One might suspect socioeconomic status, but people in a high socioeconomic class would be more likely to have dental x-rays and probably less likely to have small babies. So I don't think that would be a confounding variable here, because that would be the opposite of what is claimed. Let's look at these last two headlines. Family dinners benefit teens, and moderate walking helps the mind stay sharper. Are these observational studies? Are there confounding variables? The first one is almost certainly observational, and it is certainly susceptible to confounding variables. If families frequently eat dinner together, that means that the parental ties to their children are probably stronger. The headline doesn't make it clear what the benefit to the teens is, but I'm skeptical. The second one is probably an observational study. If it were an experiment, then the researchers would have to tell one group of people to spend a moderate amount of time walking each day and tell the other group not to walk that much each day. That feels maybe not quite to the level of unethical, but it's kind of a problem. In this case, there is confounding because physical health and mental health are tied together in ways that we sometimes don't understand. To wrap up, we looked at the different types of study, experiments and observational studies. We talked about anecdotal evidence and how it is unreliable. We talked about how observational studies cannot be used to determine causation because of, among other things, confounding variables. We talked about the difference between paired and two-sample designs. And we talked about some other problems with observational studies, both in retrospective and prospective studies.